Okay, we're going to try something different for 6.1 and 6.2, primarily because I'm in Colorado right now, and I forgot to bring my flash drive that has all my presentations on them. So what I'm going to do is I'm just going to go ahead and do an old-fashioned presentation. I do this a lot of times with my Algebra 1 students anyways. It's generally going to be the same information, just presented in a different way. All right, so we're going to talk about 6.1, ratios, proportions, and the geometric mean. Obviously, our key vocabulary here are all the words that are the primary words in the thing there: ratio, proportion, means, extremes, and geometric mean. Okay, and we'll talk about those as we go along through this section. All right, a ratio is a comparison of two quantities. You can write them in three significant different ways. You can write them using words, 3 to 4. You can also write 3:4. Okay, or you can kind of write them as a fraction, 3 to 4, like that. Okay, but basically a ratio compares two quantities. For example, there's a couple of ways you can look at this. You know, if I was talking about baseball, I could say I had 3 hits out of 4 at-bats, which we call in baseball ABs. Or there's another one would be there's 3 girls out of 10 students. Okay, you can also look at it like this. There are 3 girls for every 4 boys. Okay, so these are different types of ratios, and you can rewrite these ratios as 3 to 4, or you could do 3 to 3:10. Okay, or you can simply write 3 girls to 4 boys. Okay. Another way you can look at ratios, depending on how you're comparing the quantities, is you can look at it as part to whole. You know, a lot of times, this is kind of an easy way to set up a ratio, is part over whole. In this case up here, where we're talking about the 3 at-bats, part of the at-bat, we have 3 hits, but the whole is 4 at-bats. So 3 times that you went to the plate, you got hits, but you went as a whole 4 times. Same thing here. We got part over whole. 3 girls out of a whole 10 students. This would be your part, and this would be your whole right there. Okay? Fairly simple stuff. Something that you should have learned in 7th, 8th grade. Not a big deal. Okay? Equivalent ratios are simply what I would call reduced ratios. That's it. They're just ratios that are reduced. Okay? So if you have a ratio such as 6 to 8, okay, it's the same thing as saying 9 to 12. And if you reduce both of those, 6 divided by 2 is 3, 4 divided by 8, 8 divided by 2 is 4. 9 divided by 3 is 3, 12 divided by 3 is 4, so if you reduce either of those, they all equal 3/4. So these are all what you would consider equivalent. 6 to 8, 9 to 12, and 3 to 4 are all equivalent ratios because they're all equal to 3/4. They're just reduced, okay? So it's either ratios reduced, or in some cases, you're going to see, you know, you might see a question that says, okay, you know, the algebra classes have a 3 to 4 A to B ratio, whereas the geometry kids have a 9 to 12 A to B ratio. Who's got a better ratio? Well, neither. They're equivalent. Okay? So that's not going to make any difference. So you got to be careful there. You make sure you reduce at all times. Okay? Okay? All right, now, next thing we need to talk about, same thing when we're talking about reducing and equivalent ratios, we also need to make sure that we understand that in order to make a true comparison, they must be the same unit of measure. Okay, so for example, here I have 5 feet and 20 inches. You saw this on your end of semester review, so this shouldn't be anything too crazy, but a lot of the mistakes that I saw students make on the exam and on the review is simply not converting to like units. You have to do that in order to get an accurate comparison. If you don't do that, then your comparisons are going to be off. So here I have 5 to 20. I can convert it either from 5 feet to inches, or I can convert 20 inches to feet. I'm sorry, 5 feet to inches, or I can convert 20 inches to feet. The only problem with that is you can look here at 20 and realize that it doesn't get evenly divided by 12 to make an even number feet. And so what's going to happen is you're going to have a crazy decimal. So let's go ahead and convert feet, okay, to inches. Well, how do I convert feet to inches? I simply multiply by 12, right? So 5 times 12, this becomes 60 inches rather than 5 feet over 20 inches. And now I can make a true comparison, which is, if I simplify this, okay, 6 divided by 3, it's a 3/1 ratio, okay? So if you don't convert this, so let me show you the wrong way here. If you don't convert this and you just simply leave it as 5 to 20, you say, well, I know I'm supposed to reduce this, so if I reduce this, this becomes 1/4. Then your ratio is 1/4. Compare those two. Are they not significantly different? Yeah, absolutely. They're absolutely different. So this would not be correct. So you want to stay away from that. Again, always use the same unit of measure. Can't stress that enough. Okay? All right, let's move on to our first example type problem. All right, it says we're given a rectangle with a side ratio of 7 to 5 and a perimeter of 48. It says find the factor which they were reduced by. Okay, so these were initially reduced. All right, and now let's look at some key words here, because even though we're not taking the test, I do like to stress some key words. So let's look at some key words. Well, first thing, we're dealing with a perimeter of a rectangle. So that should automatically link you to the formula for the perimeter of a rectangle, which you should have learned again sometime in 7th or 8th grade. And so the perimeter of a rectangle is equal to 2L plus 2W. So somewhere in there we're going to have to figure out how that fits into our problem. Well, does it matter what is length and width when we're talking about a rectangle? Okay, is this L or W, or is this W or L? Yeah, it really doesn't matter, to be honest with you. So, because if you notice here, you're dealing with addition, okay, and you're dealing with multiples of 2. So in any case, because there's two lengths and 2 widths, it's not going to make any difference when you add them together. Okay. So with that being said, we also know we have a side length, our side ratio of 7 to 5. Okay. Well, if you guys remember, and I'm just going to bring a key word back in from, like I said a couple years back or last year, scale factor. Scale factor essentially was the ratio which we dilate things. So some key words you need to bring back from memory is scale factor and dilate. When we dilate something, we reduce or enlarge it. Well, how do we use scale factor? Well, we multiplied our scale factor, right? So essentially what we're looking at right now is we're looking at a scale factor of 7 to 5. So what we can do is, in order to solve this, is we can simply take our perimeter and say, okay, 2 is part of the formula. Our length now is 7 times some number, right? And then our width is 5 times some number. And it's going to be the same number because we're looking for a factor they were reduced by. And so then from here, we can simply do algebra, which is easy because we can remove this p here because we know what p is. P is equal to 48. Put that 48 there and do our algebra. So what we end up with is 48 is equal to 14x plus 10x. So 48 is equal to 24x. And then what we figure out is x is equal to 2. Because 48 divided by 24 is 2. So the answer to our question is 2. And again, as always, if you have any questions, please feel free to write them down, bring them to me in tutoring before or after school. Also, when on break, you can email me at misdgeometry@gmail.com, and I will try to do my best to get back to you as quick as possible. All right, let's look at another example. Okay, similar problem to example 1. This time we're given triangle angle that ratio is 1 to 3 to 5. Notice we have 3 ratios now because we have 3 different angles that we're discussing. So how do I figure out what the scale factor was there? Yeah, very similar to before. I know that the angles are going to equal what? 180. And so I have to take 1x plus 3x plus 5x to multiply them together. To get the x value. So if I wanted to figure it out, I could simply do 9x is equal to 180, and we know that x is now equal to 20. So our x factor, or that factor that we changed, is 20. Okay? And so then if you plug that back in, you're going to have angle measures of, this is just kind of an extension of this example, you'll have angle measures of 20 plus 60, right? Plus 100. And if we did that right, that should equal 180. 20 and 60 is 80. Plus 100 equals 180. And 180 does, in fact, equal 180. Okay? So in this particular case, the ratios are by 20. Okay? All right, let's look at another example. Okay, so now we're going to talk about proportions. A proportion is an equation of two equivalent ratios. A lot of times you guys don't realize that this is an equation, because, or at least when I teach it Algebra 1, because what happens is if we have a proportion like 48 to 24 is equal to 2 to 1, this is what students will do. They'll cross multiply or reduce, and they'll say, okay, 48 times 1 is 48, which equals 24 times 2 is equal to 48. Well, that's true. You cross multiply to check to make sure it's a proportion, but what happens is the equation part of this comes in right here. What if I said 48 over x is equal to 2 over 1? Well, yes, I know you do the butterfly, cross multiply, divide. I know that's what you were taught, but algebraically, the way it's supposed to be is that you do your cross multiply. You have 2x is equal to 48 times 1. And then there's your equation. Okay? So proportion is simply two equivalent ratios. So if I go back and I look at this again as simply 48 over 24 is equal to 2 over 1, you could do a couple different things in order to check this is true. We already showed you over here that all you had to do was do 48 times 1 and then 24 times 2, and if they both equal the same things, then you knew they were a proportion. Okay. The other thing you can do is, could I reduce this here? If I reduce that there, 48 divided by 24, you're going to end up with 2 is equal to 2 over 1 is 2, so that will also work. So you can go a couple different ways, but that's just a quick review on proportion. As an extension to proportions, I want to go ahead and introduce you to an extreme and a mean. Your extreme numbers are going to be those numbers that are on the outside. And the mean numbers are on the inside. Okay? Now, here's what I'm talking about. I'm going to actually give you a second to look. Right here, this number is an extreme. And here, this number is an extreme. Okay? This number here is a mean, and the 2 up here is also a mean. Okay? So see if you can't figure out what I mean by the extreme is the number on the outside, and the mean is the number on the inside. And I'm not talking about the number, the numbers. I mean, obviously we have 2 extremes here and 2 means. Right, if you were thinking to yourself, well, 1 is the low number and 48 is the highest number, and then 2 and 24 are in between, right? That's where you get the inside and outside. So 1 is the extreme high or low, and 48 is the extreme high. And the mean, the 2 is in between 1 and 48, and 24 is in between. Like I said, 2 and 24 are somewhere in between them. Okay? Okay, so knowing what the extremes and what the means are going to help you when you are solving for the geometric mean. Okay, so this is not right here, just to clarify, this right here is not the geometric mean. Mean and geometric mean are two different things, okay? So keep that in mind. But you're going to need to know this vocabulary and how to identify these numbers so that you can find the geometric mean. Okay, so let's go ahead and talk about geometric mean. Okay, so we're going to talk about the geometric mean. The geometric mean is the positive number that satisfies a over x is equal to x over b. Okay, and so that's obviously a proportion. And so the way we figure this out is we use a simple equation. If we know our proportional equation, we would know that you have a times b is equal to x times x, right? Well, x times x, so you end up with a times b equals x squared. Well, if I want to solve x, okay, because that's our geometric mean, so our geometric mean is the x. Okay, so if I want to solve for x, how would I get x by itself? Because I can't solve for x squared. That's right, you square root the x squared, and you square root the ab. So our geometric mean is x is equal to the square root of a times b. Okay, I know that seems a little complicated initially, so this is what we're looking at. This is our focus for the geometric mean. And I know it looks, like I said, a little complicated. But rest assured that oftentimes, and this is the new thing that we're dealing with, oftentimes you're going to be given either the geometric mean or the A or the B. Okay, so let's take a look at an example problem of this. Okay, so here's our example 3. It says find the geometric mean of 12 and 27. Okay, so remember, initially our geometric mean, we're looking at A over X is equal to x over b. Well, it's given you two numbers because essentially x has to be what? Yeah, x should be the same number. So if that's the case, we know that 12 and 27 represent our a and b value. Is it going to matter where you put them? Well, no, because you're still having a proportion, so it should still equal out the same. So what we'll do then is we'll put a is equal to 12 over x and x over 27. And now as I go ahead and solve this out, I'm going to end up with, I'm going to come over here. It's going to give me x squared is equal to 12 times 27. If I continue to work this out, I have x squared is equal to 324. But now I want to solve for x. I don't want x squared. Okay, so if I go ahead and square root x squared, I end up with x. And square root of 324 is 18. So the geometric mean there is, between 12 and 27, is 18. Okay? Now, if I wanted to, and I wanted to check something, I had 12 over 18 is equal to 18 over 27. Let's see if that's right. Let's reduce. Let's do it by reducing. I don't like to do the cross multiply unless I have to. So let's reduce this by 3. So we have 4 over 6. Actually, we can reduce it by more than that. Let's reduce it by 6. Excuse me. 2 over 3. And over here on this side, let's reduce it by 9. You end up by 2 over 3. So those are equivalent, right? Okay? Pretty simple, pretty standard. Okay, and you're going to have some other variations of the equation, the questions that might say, it may give you the geometric mean, and it may give you the a value. So it may say, okay, you have a geometric mean. You have a geometric mean equal to 10, and a is equal to 5. And then it wants you to find b. Well, how do you do that? Well, you simply do the a over x is equal to x over b, right? And just plug it in and do your algebraic, you know. So you have 5 over 10 is equal to 10 over b. and then you end up with 100 is equal to 5b. Divide both sides by 5, and you end up with b is equal to 20. Okay, so that's another type of problem. I just wanted to show you that real quick, just so that way you don't get freaked out if you don't see that later. And that's pretty much it. Your homework is the same homework I gave to you on Friday. I also posted under the announcements on Blackboard. Hope you guys are having a great Christmas. I hope you're having a great vacation. I know I am. I will see you guys soon.